Import pandas as PD. We will be using the dataset from the UCI machine learning repository containing information about breast cancer patient. First, we need to identify the instances and attributes. Second, we need to identify the missing values or more attribute values. In some cases, the information was not collected. Some attributes are inapplicable to the data instances. Observe that only the Barnacli column contains missing values in the following example. Missing values in the Barnacli column are replaced by the main median value of that column. Next, instead of replacing the missing values, another common approach is to discard the data points that contain missing values. That can be easily accomplished by applying the drop-na function to the data frame. In the example code below, we will draw a box plot to identify columns and table that contains outliers, except in the Bernoulli originally stored as into 64, whereas the values of the Bernoulli column are stored as a string object. The following code shows that the result of standardizing the columns of the data. Note the missing values is none, are not affected by the standardization process. In number 7, we need to identify the number of rows before discarding outliers and the number of rows after discarding missing values. We see the output 699 and 632 in missing values. In this table, we need to identify the duplication of data. First, we need to check for duplicate instances in the breast cancer dataset. Here, we see the number of duplicate rows is equal to 236. Although such duplicate rows may corresponding to samples for different individuals, in this hypothetical example, we assume that the duplicates are samples taken from the same individual and illustrate below how to remove the duplicated rows. In the next table, we will use the daily precipitation time series data for a weather station located at Riyadh Metro Airport. The raw data was obtained from the climate data online website. The daily perception time series will be compared against its monthly value. In this table, we load the perception time series data and draw a line plot of each daily time series. The time series can be grouped and aggregated by month to obtain the total monthly perception values. The resulting time series appears a very more smoothly compared to the daily time series. Now, you see the table below. This is a monthly precipitation variant. This table, we will apply sampling with replacement and without replacement to the breast cancer dataset obtained from the UCI machine learning repository. Now, you see the first 5 records of the table. And the next table, you see the sample of the size tree is randomly selected without replacement from the original data. Now you see the differences of two tables. In this table, we randomly select 1% of the data without replacement and display the selected samples. The random state argument of the function specifies the seed value of the random number generator. In this table, we perform a sampling with replacement to create a sample whose size is equal to 1% of the entire data. You should be able to observe duplicate instances of the sample by increasing the sample size. For the equal width method, we can apply the cat function to discretize that attribute into 4 bins of similar interval widths. The value counts function can be used to determine the numbers of instances of each bin, and for the equal frequency method, the qcat function can be used to partition of values into 4 bins such as the each bin has nearly the same number of instances. In the example below, we illustrated the application of PCA to an image dataset. There are 16 RGB files. Which of the files has a size of 111 times 111 pixels? The example code below will read each image file to convert to the RGB image. In the next table, we import pandas as PD from the sklearn that decomposition is equals to import PCA. Observe that the image of burgers, drinks, and the pastas are projected to the same region. That's all. Thank you.